Um, what we've done so far is we're just parsing the input. We are creating robots to mine minerals. And currently, I'm trying to parse these robots, and so we get some blueprints, and then we run it, and then we're supposed to figure out how to get the maximum amount of geodes or something like that. I'm eating amazing cookies. My read input is going to be file path to IO input. Read input equals map. What's going to be parse the first dot read p to s parse blueprints over read file. This might work to read input date 19. Okay. I'll explain better in a bit what we're trying to do here. Okay, this is annoying. Maybe it is working, but just not. Let's do here. Oh, she's not doing it. It's quite annoying. Let me just change the example to be exactly the same as the input. Okay. Map. Okay, we're not gonna do this. We're just gonna do read map read dot lines. Okay. 42 314 27. Can we parse the input? I'm guessing we can. Yes, input was parsed. Okay. So we have these, we're trying to collect geodes, and we're trying to collect, geodes, we need geo collecting robots. To make those, we need obsidian collecting robot. To need obsidian, so we have obsidian collecting robots. And then we have clay collecting robots. To make any type of robot, we need ore. So we have an ore collecting robot. Each robot can collect one, so we can make robots, but we need robots to collect resources to make more robots, right? Mm-hmm. Mm-mm-mm-mm. Okay. You need to figure out which loop is the maximum number of open robots after 24 minutes by figuring out which robots to build and when to build them. Mm-hmm. Okay, so we can select actions at each step. Okay. Oh. I have a cut on my toe. Okay, let's model the state. So our data state was our state. Okay. So this is or robots in clay robots in obsidian robots int geode robots int. Okay. Let's actually make this just robots. Int, comma, int, comma, int, comma, int. Okay. And then it's or clay obsidian geode. Now stocks is gonna be the same. Int, comma, int, comma, int, comma, int. Update state. Update state. Now let's see, this is our state. Our state. This is gonna be rs comma sts. And I can just add these all, like I can add, so if I have like one clay robot, right? One ore robot, I will have one more of that, right? So rs add OC or clay obsidian geode or robot, clay robot, obsidian robot, geode robot, OCBG and time up. This is the time update. Okay, and this is just gonna be O plus OR, B plus CR, B plus G plus GR. So when the time passes, went towards the start building click learning robot, and then we get the one ore. Okay, now let's do factory. This is just what the factory is doing. Int, comma, int, comma, int, comma, int. rs add let's call this just mining. Okay, so this is actually gonna be a bit different. Empty factory. Gonna be okay. The factory is gonna be equal to empty factory. Now let's include the factory here. FO, FC, FB, FG. Robots equals OR plus FO, TR plus FC, PR plus FB, PR plus FG. Let's have these actually be the actual cost. Each ore robot is so it's clay and ore. Okay, so this is gonna be the ore cost. And then this is gonna be obsidian robot. So OB rock 0, OBRCC 0,0. And then this is GROC. So geode robots cost ore 0, 0, GRCC. Type crypto quipple is equal to int, int, int. Quipple. Okay, this is how we update the state. Now, let's actions. Data action. Okay. Pass or build. Build or build clay, build build a, this is the last one, build geo deriving EQ show or whatever. Now take action, takes the state and the action and returns the state. Take action st. Maybe I want to have it like this. Okay, let's just have it like this. rs at r state Language record wildcards. Okay, okay, so build or it's gonna be rs factory equals 1, 0, 0, 0. Let me see. Add quipple. 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 Add quipple. A, B, C, D. X, Y, Z, W. A plus B, A plus X. A, B plus Y, B plus Z, B plus V. So stocks is just gonna be our state. Stocks is add quipple stocks robots. Robots equals add quipple robots factory. And factory is equal to empty factory. Okay, this is simpler. So build, so then we add one factory is like that. That's how the input here, the blueprint. BL. BL. And let's actually have this more. Or robot. Yeah, Clay robot. OB robot. And Geo robot. That's gonna be O equals quipple. Or robot OR CR OBR GR. Yeah. Okay. Language overloaded. Bird. Dot. So if I want to build an OR, the factory negate quipple is equal to quipple to quipple. And then the stocks is equal to rs dots is equal to stocks add quipple negate bl dot o or negate quapple. Exactly the same for build clay. And so there it's the OC, the CR, and then build ops is gonna be the same. And then build geo is gonna be okay. Now let's simulate the example. What do they actually do in the example? Let's keep this here and keep this here. So every minute, let's see. EX acts is a list of action. EX acts. So first they pass. And then build clay. And then pass. And then build clay. And pass. And then build clay. Pass. Pass, build OBS, build clay, pass, build OBS, pass. Let's say here, let's review it before we go too far. Okay, so pass or clay. Pass. Okay, pass clay, pass clay. Pass clay. Pass clay. Pass clay, pass clay. Pass clay, pass clay, pass clay. Pass. OBS, clay. Pass. OBS. Pass. Build geo. Pass geo. Pass build geo. Pass build geo. Okay, so we have pass build geo. Pass build geo. Pass. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24. Okay, so run round. We can take the state and we take the action and give a state. Run round is equal to a st equals takes action, and I need the current blueprint also input. Take action bl act. Take action bl act, and then we do mine take action bl st act, and this and then we did the thing where we do mining Okay, now let's do initial state is equal to our state. So I have the RS and I have the one. So I have the robots. Right. Stocks equals empty factory. Let's not call it empty factory. Let's call it empty quapple. Quapple. Empty quapple. The so the factory is equal to empty quapple, but the robots is equal to 1,0,0,0. For state. Okay, let's make this bigger. Let's just call this here script. Now, so what I think this is gonna be some sort of dynamic programming, like schedule optimization, cost constraint solving, blah blah. Okay, so we have the script. Now, what I want to do is fold L. Okay, and then we have the XX script. Now I take the input. I take the state, initial state. I take the list of actions and I return the final state. XX script. BLAI state x equals fold L. Run round BL. Now I state act. Dot XX script, and it's gonna be And the inputs are actually here. I don't need to take in the ice state because I know what that one would be. Okay. Exec script initial state. It's okay. Ex It doesn't look because it cannot print. Oh, this is for show state. Deriving show. But day day 19 that I just we're running to non-exhaustive patterns in function take action. Take action. Okay, rs pass equals rs. Okay, it seems like there's something wrong here. 1 or collecting robots, 4 and then 2 and 2. I have 6 ore, I have 41 clay, 8 obsidian and 9 open geodes. Each geode robot let me just read this. I just wonder what the inputs are. Make sure we got them correct. Move this trace show here. So each robot costs 4 ore, 2, 4 ore, 2 ore. Each of 0 costs 3 ore and 14 clay. It's 2 ore and 7 obsidian. Okay, so this one is correct. Take action. Mining. Stocks equals add couple. Stocks robots. Robots equals add couple robots factory. Factory equals empty couple. Let me just It's probably because I'm folding the L, but I should be folding R. Okay, let's see. Ding, 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 ding. Okay, let's just take that first one. So I started with 1, 0, and then 2. And then I have 1, 1, and I get 1. Okay. 1 or you don't have 1 or, you have 2 or. 1 or collect is 1, you don't have 1 or. New collect how about you know have one of them. And then I have 2 ore and 1 clay. And then I have 1 ore and 2 clay. Geodes, they produce geodes. Okay, so there you get 9 at the end here. Bleep. 2 and 3 and 3 and 8 and 3 and 12. They're probably not the same. Okay, I haven't actually computed. Yeah, okay, so it's not the same series of actions. All right. Now let's compute the possible actions in the current state. we are going to be doing let's see, possible actions. Possible actions. Input, so the blueprint, we need the state, and then we get a list of actions. Possible actions. BLST. Compare can pay quapple let's pair these up. Pairs cost of this one takes an action and returns. Okay, so for actions, I should actually do EQ show ord and okay. Cost of action, a input to action to a quapple. Now cost of pass equals empty quapple. Cost of BL and a build or is equal to BL.OR. Cost of build clay equals BL.GL. Clay robot cost of build OBS equals BL.OBR and cost of build a geo equals BL.OBR. No, G robot. Okay, now possible actions given an input and a state is equal to is payable takes two quapples, a quapple. Let's just say ord quapple. Compare quapple is ordering. Now compare quapple. Now let's not do it like that. Is payable. Quapple bool x so A B C D X Y Z W is equal to A larger than X and A larger than equal to and B larger than equal to Y and C larger than equal to Z and D larger than equal to W. Okay, possible actions, action. Possible actions, BLST equals. Now we will do, we will enumerate the tuples. Pass to. Okay, so these are all the build geo. Let me see. Enum. Haskell enum from to. Why? Why does it error here? Main bound to max bound. Maybe it's not done. I think this might be actually a error, like the overload record dot error. Okay, but let's say here, filter is payable st dot stock. Dollar map a cost of PL. These are the possible actions in the state. Bing, ding, ding. So let's now, during our time thing, let's just do a trace show. Where rs prime equals trace show rs comma possible actions. We can't do it here. Okay, rs prime xx script a SDA run around SDA, but I also want to here trace show ST comma possible actions BL ST. On each of the in each of the ones we take one. So first we can pass, then we can pass, then we can pass or build clay. Then we can pass, then we can pass. Pass or build clay. And ST, let's do A. Okay. What do we did? Okay, pass, build clay, 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 pass, build clay. Okay, and now I want to search the space How do I do that? Well, I can just generate all the possible routes. And then we do that. We're gonna get a lot of combinations. Okay, so let me check here. Explore space input current state. Gonna generate a list of actions. Okay, so first of all, where pos equals possible actions PLST. Now, then I want to do for each of these. So TAA equals so explore space BL take action. So run round so this one will do BLSTA. Run around BLSTA. Explore space BL TAA. Okay. Concat map TA pause. Okay, and now for all, these are all the actions. Quite a lot. Let's do okay, now we're gonna explore the space BL initial state. And I'm gonna map take 24. Let a path there's gonna be a lot of paths. Let me just start by saying what are the possible like kind of 3 paths. There's not gonna be a lot, right? Because the first things we can do is just okay, this is not being lazily valued at all. Ah, because it's exploring first all the paths, first all the passes. Ah, then I'm not actually TAA. And I never actually returned anything. Um. Ding, 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 ding. Oh, I need to see here. This is not being evaluated in the way that I thought it would be. Okay. Ding, 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 ding. Maybe it's because I do fall down. Okay, so let's be very careful here. Map A to so TAA pause. Ding ding ding. Mm. Ding, 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 ding. Dun, 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 dun. What is the one to select next? Okay, we have the possible actions, and then we let SFA state from here, because TAA in the state from here is a list of actions. SFA. If FP from here, VA equals map A SFH. So does this not give a list of actions? But it is concat map, right? Because but this will not give me the. Oh, now it did. And now it's just always giving me the first one. Let me see. Let me see. Let's do something like this. TAA is map A onto floor spaces. TAA takes action into where's the possible actions? Okay, well what if I just have the number here? So int and explore space and 0. I'm going to just do the empty list. Concat map TA a concat map TA was no good. Okay. So here I have to, or not the empty list, the empty list. How many possible paths of 24 are there? Maybe not trace show then. Scratch it. How many length type paths of lengths? 5 are there. 10. Okay. Okay, can I eliminate a lot of them after 12, maybe? Let's say, if they haven't started generating geode at time 12, they're obviously not doing well. Let's see, the best one here builds their first geode cracking robot. Minute 18. I do get up to 18. And of course it's a lot harder for the input because Okay, let me see. Eval action input state. Where is? Let's make a here. Let's make a we have input st act is equal to where final state equals run script check script act bl st. Let's make this take in state. Let's see. This is you know, 1,000 times sl.geo sl.stocks stocks equals FOFC FBFG is equal to final state dot stocks. So let's talk about 1 million times FG plus 10,000 FB. Now let's say input state list of actions. Now let's prune and let's just say that BLST equals take. Let's take the top 10, 100. Take top 10, reverse, sort by compare on eval BLST. Import data dot list sort by import data dot function on print. So print path is this. Now we're gonna print prune we're gonna take a top n, right? Prune, and let's just say print take the past 5 paths of paths. BL1, BL2, BL1 initial state. Initial state, initial state, initial state. initial state. Let's do it for 12. Okay. We're taking the top 10. Let's take the top 100. Okay, now let's take the top 10. Now we are gonna say a final path is equal to so map. So we're gonna take the path the one so acts, and we're gonna do a explore space 12 bl1, and then this is gonna be xx script act bl initial state. I get that when I'm running it again and again, but it's okay. Explore space bl xx script bl1 initial state. Yeah, that's gonna be the state. And we're gonna do this on the what is it complaining about here? The last statement, okay, and print prone length dollar prone one 1, BL1, A. This is extremely naive search, right? Okay, now this is the first one. Best one is equal to this. Now let's print exec script. Best one. BL1 initial state. What's the final state here? That certainly is the best one, but it is not wrong. It's run right. Okay. Pass, build, play. Why is it no. So ding ding ding. Oh, maybe it didn't work right if I did fold out right. I think I'll have to have this as EST and then okay, I seem to find the same maximum as the first one. So pass, build, pass. Oh, nice. Okay, what about BL2? Oh wow! Little Annie saying okay. Thanks, little Annie. And you highlighted your message with all your channel points. Not bad. This is like iffy, right? Because we I didn't do the 2 here. Probably not enough fusion going on either, right? And here I'm still just taking the top 10. So I should definitely be able to cut some of them off at the end. As you can see here, okay, let's now do some optimization. Right. Possible actions. Let's just have that be if is payable 50.stocks cost of BL build geo, then else. So this is our one. The process will not die. Let me see here. Yeah, it got killed. Okay, so we build geo if we can. No need to explore anything else there. Now let's just see here. To use. Let's go all BL2 here. Now BL1, BL2, and let's this BL2 use equals BL1. Okay, so you know, if we can't build the geo robot, we are going to build the geo robot. Okay, that's as simple as that, really. Let's see here. Okay. I'm also like keeping a lot of them around, right? Which I don't need. Yeah, I think the memory usage here is what kills it, actually. What if I do it in a couple of steps? Wow, little Annie can only chat if she highlights her message. Ah! We got 7 viewers. Thank you for tuning in. How is everyone? Is my chat... Oh, how's it going? Hey Christian. It's not going great. I'll tell you that. Killed. I keep running out of memory. Which is not great. Okay, so paths. So okay, so I'm gonna do this a couple of times. Okay, we're gonna do the run round and then we're gonna have the initial. So we're gonna have the state and the state, and then the input actually. Input, and we're gonna take a list of actions, and we're gonna return a list of action. Okay, run. Okay, this is not run round. This is gonna be a run a few. Okay, so run a few is going to be a where. Okay, we're gonna do paths. Okay, so let's see. This is a moves, and then we're gonna look up. So I had some moves, and then we're actually gonna do plus a 100 times FC plus FO. FO. For paths equals explore space moves After prune to moves, BL to use. This is gonna be BL, so BL, and then state. BL state. Prune equals prune. After prune st. Sorry, and then this is not state. This is actually a so far. Okay, I'm actually gonna do here. First, I'm gonna prune. Prune after prune so far. And then equals concat map so far. Let's do just the same, exactly the same. Act map act dollar explore space moves bl exec script, and this is false act bl sd. Pruned. Ding 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 ding. Moves after prune. BLST so far. Prune. Okay, this is gonna be actually like this. Prune after prune. Oh, I need the here. Let's see here now. So let's do let fst equals let bl to use equals bl1. Now run res equals run a few. We're gonna do 6 moves and we're gonna prune to the top 10 of the BL to use initial state. Then we're gonna start off with the empty action. And let's print out what we get from that. My poor VM is always a bit unhappy after it runs into memory issues. Okay, so these are the first few. Let's see, what if I just do 3 here? Okay, now run res prime is gonna be, I'm gonna do 3 after that, and I'm gonna give it run res. And then I need to print run res prime. Now, okay, let's do this a couple of times. 6, 6. Okay, that was quite fast. And now we're just taking very few steps at a time. Now from the last one, I actually... So this is valid only if like the heuristic that we chose means that the eventually best path is in the top 10 after 6 steps, which there is no guarantee of. Let's go geodes. Input state action int. Map print run res. Geos, and then I need to give it all the stuff. BL to use initial state. Initial state. Best one, okay. Okay, we get to print maximum. So here it gets to 8. Okay, so that was too bad. Let's bump this up to 100 each step. So it's not even in the top 100. What if we do a 25, but here we run a few. But we do it 3 times 8. And we do find the best one. Yeah, but what if we do BL2? Then it only finds 10. But we would want 12 there. Nah, this is too long. And this is the one we did initially, right? And it's gonna run out of memory. I could, you know, exec the space and then like not remember the actions. Just give it the int kind of. Explore space 0 st equals okay, and then here instead of doing concat map, so we got the possible actions. Now TA takes a action and we will return a list of ints. Okay, let's see. And let's just do explore max. Print explore max 24 PL to use a initial state. So here's no pruning. Okay, that's really slow, right? Because then it has to kind of fully evaluate everything before, and we can't take it and blah blah blah. Mm, mm, mm. But this is the one that will like, will definitely work, right? Maybe we can like jump it, right? So we find the best strategy to get one geo, right? Then we don't have to go all the way. I think that could work, yeah. Let me say BL2 here. And there's nothing after 18 move there either. You get what I mean, right? So we find like the best one to go get to 1. Yeah, this is something you would probably use like some dynamic programming scheduling algorithm. Okay, let's go Reddit advent of code. I want to see what people are doing. Maybe I could do like a shortest path algorithm where the destination is I want to find where the destination is oh oh Mhm. Okay, so yeah, okay, let's try and do this with the BFS. Okay, so the neighbors function takes the so neighbors here. Neighbors let neighbors equals a. So we take a list of acts and we do possible actions. BL possible action BL to use. And then XX script false act a initial state. Okay, this is the neighbors. Okay. Where pause equals possible action, where pause equals this, and a map p act plus plus p. This is the neighbors function. We'll have to modify modified BFS. Import data.set qualified as set. Import qualified data.map as map. Import data.set set. Import data.map map. Okay, now this BFS here will be the, so this is not the neighbors, so neighbors. Neighbors B, that would take input and state action to list of action. Neighbors BLSD equals, and here we do this we have to take a list of actions. The list of actions. Maybe I should do it differently. Neighbors take a state and a list of actions to a list of state comma action. Now I'm gonna say, so not end. This is gonna be P2 bool. Can I do that here? So A2 bool. This is BFS prime. So instead of the end here, I'll have end F. A2 bool. No, so then I'll not have Q is equal to end. I'll have a end F Q. Otherwise it's the same. So it's BFS with an end condition. Now let us use BFS here. BFS let BRes equals. So I had this neighbors function somewhere. Let me just undo everything here. Okay. let's say st comma act for possible PL to use, and then this is actually PL comma act. This is actually st. And here I'll have, so this makes a P, and then we'll go and say run round BLSTP comma x plus plus P. This is the neighbors function. Let me just say that BFS is equal to BFS prime NSE NS compare, and then we're just going to say EQ equals compare EQ, compare EQ. This is the neighbors, is going to be this. BFS BFSP P is equal to so the neighbors function is going to be BFS prime, and I have to export it. BFS prime, and the neighbors function NSBL to use. Okay. And then the start state is initial state and empty list. And the end function is going to take in an st and the list of acts. I don't care about list of acts, but I'm going to say that what I'm looking for here is a st r state stocks equals don't care G is larger than 0. There's no word state. Okay, let's just derive that. Now let me do that here, and let me just print BFSP. So Okay, it's actually quite slow. Or let me write it again. NSBL. Let's try and find it. Like, what is the shortest path to make clay? Okay, so the shortest path to build. This is the shortest. This is the shortest path to get clay. And then we just go here. Just. Okay, and I actually just care about the last there. Just a BFC. F clay. BF clay. Print F clay BF clay. So this is the first. This is the shortest path. Get clay. Now, starting from there, what is the shortest path to get obsidian? F obs, BF obs, and then we're gonna start off with F clay, BF clay. I didn't print it out. Okay, now let's see if we can use this to say best first. Geo, BF, Geo. I need to print it out. I wanna reverse these actions actually to make it so that you pick something else first. I like how we're doing all these optimizations and now we're still worse than when we started. Ah. We started off with the wrong path. Ah! And now it worked quite well. Let me see. PL to use. What if I use BL1 here? Okay, so, and then I want to do, then let me do actually something here. So from this starting point, explore. Okay, maybe I don't need to even reverse here. Okay, and now I'm gonna do print explore max length bfgeo so 24 minus bfgeo and the initial then we got field to use, and we have the FGO. Hiya, Reichert. How are you doing? So I think these are okay. Let me... What if I bump up here? I am doing the advent of code. Day 19, and it's well, it's a lot harder than, yeah. And I even said I would stop right at this point, but I feel like I'm almost onto something here. Ah, thank you for the follow. Let me just see. Okay, and then I'm gonna say exec script false. What does it say? Exec script. Exec script false. And now I'm going to, because it like the last action that it does might be bad. So exec script false, and then init pfgeo, and we are going to say bl init initial state, one step back. One step back. bf build clay build exec script init bf clay, and this is bl to use. So from here, I'm actually gonna say it's not bl. I'm not gonna say f first clay. I'm gonna say clay build and then I'm gonna say init pf clay. Okay, now we're gonna do this, but we're gonna say clay obs g. And we're gonna say obs geo. Okay, clay build. Clay build. Let's paste it. We say obs and geo g, and then we say clay obs g. We take a step back. Oh, but it's still saying that should yes, we've been at it for 3 hours already. We're not stopping right. Not stopping so far. Let's see, geo build success scrape init pf geo. init build to use fgo geo build. Ah, there we got 9. Oh, very good. What does it say for BL2? Seems like rushing to build the first geode is not the best option for the okay, what do we just do here then? Init geo obs geo. OBS clip. That is funny that that rushing the first OBS build the first rushing to build the first OBS. I'm from Iceland, Record, but I'm in Sweden right now. Ah, no. Okay, now I know why. Because I copied too much. That is a bit sad, actually. I always try to do something when I can. But then it says 7 there. Okay, so this one was if I search for the shortest path to build 1, no 0. What if I search? I want to be as passive as possible. I'm hoping, yeah, this works for the example. So we kind of rush, we find the shortest path to but it's really bad at kind of figuring out because now it's like trying to let me actually see if I can speed this up a bit. Okay, let me... exec rev script. And just paste this, call it prime. This is exec script prime verbose BLT exec script. Now I don't have to reverse it. Let's see here, initial state, and then I just run the tail of VF play. That's a bit quicker because I'm not like adding to the back of the list. I'm always adding to the front of the list. But it's giving me wrong. I have to add to a name. Okay, neighbors works. Now why does this not work? B.X. Whoosh. Sorry about that. Okay, how about not checking the stocks, but checking the robots? Hmm. Okay, so now I found the best one to get to 1. Let me just actually use the, I don't care about this init here. Why did that take so much? Why was that so much faster? Okay. FGO1, BFGO1. BFGO2. This is the quickest path to 2 robots. Okay. Can I get to 3 robots? I can get to 3 robots. Okay, I cannot get to 3 robots. What about, okay, explore max. -24 minus, maybe. Okay, so who's going too far, that one? This is a bit irritating, right? So we find a path. It's the fastest path to build the Geo robot. Okay. So can I somehow like take this path and optimize it? What is the script? No, what is the actual path that we want? Pass, build clay. Pass, build clay. Pass, build clay, build clay. What if I skip this one? Initial state. Okay, so if I rush, okay, that doesn't matter actually. But okay, so yeah, I think I've tried this before, right? And it was very slow. Maybe if I reverse possible actions. Okay, I mean, so I do know that, you know, brushing clay in the beginning is the best thing to do. There's no need to look at anything else. Mm-hmm. I mean, according to the script, this is the like the correct, right? So like at on turn 18, build Geo. So question is, can I somehow kind of take the path that I have and improve it? That's not it. Largest number. Okay, 12. That's not. Okay, let's see. Let's write depth first search. Audio write depth first search. We don't have these empty sets at least. Okay, so let's see. Depth first search. Oh wow, no. Let me just refresh. Okay. Okay, depth first search. I have this scene. CPSQ. DFS prime. So this is the scene here. It says is a discovered function. Okay, so let me see. Ends equals neighbors start. EFS prime, and then this is a identity map of me. So DFS prime. Scene. If the path is empty, then we get. Okay, let me get nothing. Well, let me get left scene. DFS prime a scene AAS equal case DFS prime scene DFS scene and then this is curve case NS neighbors cur of. So if there are any neighbors, then we do of, so nothing, then we just do left scene AS case DFS prime scene set dot insert a set dot insert scene of case filter not set dot member flip set dot member scene. If there's no new neighbors that we haven't seen before, then otherwise give us a scene. Oh. Okay, so let's say work. EFS prime. Hmm. I think DFS is like that. Now let me try doing something here. And DFS ELST is equal to where pause equals possible actions ELST map P to run around VL SDP. Okay, I should put that there. NTFS, BL. Now let me run this TFS and BL. And then we give it the starting point, which is going to be 0 initial state. And the end function is supposed to be this, the same as here. So how long does it take for it to figure out the path does not exist? For BL1, that is. Okay, let's now see. Alright. Do. We just write this loop here. Go and ends. Equals a case. So if of nothing, we return n minus 1. Just something. Yeah, this is like the brute force, right? Just search it until you find something. Me. Was quite fast for that one. Now here we wanted to see it to get to 12. Let me see. Let's see if we can like prune this even farther. Let max more more equals a maximum. BL.OR BL.OR Don't try this at home, kids. Okay, let's see now. The max or reserve. It's gonna be the maximum. 0. So this is gonna be the 0th index of a map index q over this list. BL.OR BL.Ober BL. This is the obsidian robot. BL.Gear and BL.Gear. That BL equals BL to use in So if I have more ore and I have not built a robot, then if I could have built a robot but I didn't, then I don't want to take a look at that state. Wow, that finished really fast. Okay, so I think this one works actually. Task 1. Input. Task 1 takes in this input. BL2 used. Okay, go 0. Int. Let's comment out all this. Best first search something. Now let's just say print $map map task 1. DFS, we're not using DFS res here. And it doesn't like this. So this is my simple heuristic. We map task 1 to int, and then we do zip with $1, and then what I want to do is I want to get the ID and the value, and I want to return I times v, and we're going to take the sum of this. We did try a lot, right? Okay, we get the result here. Now let's try this for the input. Oh. Oi. My heuristics are too harsh. Yeah, see, it doesn't work for the example. But why is it giving 0 here? Each robot costs 4 ore. Each clay robot costs 4 ore. Each cylinder costs 4. 19 clay. Right, okay. So maybe the right answer here is... okay, yeah, no way, right? Okay, the heuristic is just off. What if I do here 4 times max or res? So I could build any robot. That would be a lot slower, right? Doom, 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 doom. Can I accelerate it by... No, so not saying here. I can't, right? Because I might be... Yeah, that. Okay, so we're gonna check that nobody's using clay. Let's check. What about something like this? Well, 57 was too low. Let's go back to the subreddit, see if we can find some good heuristics. Okay, so robots. ORCRBR. Okay, so if so that's what they're saying. If OR is larger than or equal to res is 0, okay, and now okay, let's say that if OR is larger than reses of 0, then I will return empty. Or so if I've built more robots than I'll ever need, CR larger than reses of 1, or BR larger than reses 2. For any resource that's an R that's not a geode, if you already have X robots creating resource R, and no robot requires more than X of resource R to build, then you never need to build another robot mining R anymore. Okay, so yeah, so this is basically if I built too many robots. Okay, now for the second heuristic. And okay, for any resource, if you are the X robot, no robots require more instead. So X times T if OR, so number of robots times time minus n plus a plus O no, T is a time minus n. So T OR times T plus plus O larger than a t times but then it returns. Okay. Let's see. Was it the? Oh no, this one is 2. So let's check the first one here. Equals something. Oh no, I had to close it like that. Okay. If a OR larger than or equal to reses of 0, okay, let me see here. In DFS, pause equals pause prime is equal to heuristics st heuristics equals h of st and st pause prime for h of n and r state stocks equals or stocks, clay stocks, obsidian stocks, robots equals or robots, clay robots, and obsidian robots equals. Now, so hn empty equals empty. Hnf pass equals so pass of hn st pass hn and strs. Now, okay, let's say that I'm looking at the the build. I always want to, so I don't care if I'm looking at build. If I'm looking at build geo, I always want to pass build geo. Okay. That's pretty simple. Okay, now if I'm looking at a build or where rest equals h and st at h and strs. Okay, and then I'm gonna say if OR larger than or equal to reses of 0, or let me just do it like this, then rest else build or rest. Okay, let's just start with these heuristics. Case AC's case. Build or ACS. A okay, build clay. Now then I want to see if clay robots are larger than 1. Then I'll build OBS. So here's equal to OBS. BR. Then Okay, so this is the first two, and now we want to boom in the second one. So this one says OR times T plus O. Larger than or equal to T times just do like this. Let's hope this works. It's slower for sure. Let's hope that means that it's considering more things, right? Just making some chess moves. Gonna chess this thing up. We got one chess here that's completely lost to do. Sacrifice my queen. Yes, I do believe this one is lost as well. Let me resign. Rematch. That is just what happens sometimes. What did I say last time? 1257. Too low. Let's see. 1404. We did task 1. We were almost there. We had the DFS, but we needed the good heuristics. We got them. Yeah, found the phone. You're not hurry. You probably need to have 32 minutes. Okay. So, task 2. Task. And task 2, task 1. This one takes some time as well. Task 1 input to int task 1 equals task n 24. Okay, task 2 is equal to task n, but this time with 32. And take 3. Let's see what happens. I mean, yeah. We got this. Let me just see. Alright, this is gonna run for a while. Let's actually not care about this. Let's just care about this. $32 and okay. Let's just leave it running. After we've built the first obsidian robot, don't even look at building any ore robots. Let's see. Let's try some of these crazy heuristics. Build ore if OR is equal to ore. It's a simple one. If we build the first obsidian robot, don't even look at building any ore robots. We are larger than or equal to 1. If we built the first geode, don't build any more clay robots. If GR Mm-hmm. Okay, that's also one good point. I can immediately during update kind of unify these. Git add day 19 git status add update git add update git commit VBFS. Okay, we delete all this stuff. And the eval and the export space and the exec script. Okay, this is where we build if possible. Wait, I never. Ah. Okay, run round. Okay, so okay, this can actually then be just G. So instead of saying GR is larger than equal to 1, I just say G. Okay, and now I never need this BR. Okay, then I want to say run round. And here I want to say time minus n. That's how much time's left. Run around. Time minus n. Okay, and then find run round. What did I put it? Maybe I put it here, yeah. E, and then it's gonna be int take action t. No, take action t. Take action. Take action. So here I'm gonna say an int. Okay, this how much time is left. I don't care in this case. I don't care in this case. I don't care in this case. I care in that case. I don't care in this case. Wait, let me see. Money. Ah. I actually prefer to be here. Yes, T-1, right? That's how much it's gonna make. Or can I memorize this somehow? Hey, Aaron. Thank you for joining. It's going okay. And I had to take a hint. But it's still very slow. And we're still waiting for it to solve task 2. People are saying, oh, I added these heuristics and it went from 7 seconds to 1 second. But mine is taking 7 minutes. So I'm hoping... Yeah, so I went on the subreddit, right? So if you get it wrong, like the answer, it's like, oh, take a look at the subreddit. And so I took a look at the subreddit, and I'd already kind of... I was doing breadth first search first, and then I was doing like depth first search. And I kind of knew, okay, this works, but I need to prune the search space. So I went to the subreddit, and there they talk about a bunch of heuristics, which I've implemented here. Which is, you know, I don't know. It's not as nice, you know, but this is really just kind of, oh, let's take, you know, domain knowledge about this and put it in there. And I feel like, you know, that's fine, right? We can dump in some domain knowledge there. Some heuristics. Yeah, exactly. How are you, Aaron? I want to say the 57. This is the advent of code. 2022. Day 19. We used to be, like, the first few days, it took us like half an hour or so. And now it's taking many hours. I think yeah, on Saturday it took like 7 hours. Oh, it's this it's fun. It's this so hints. So it's this advent calendar, right? So you get one programming problem per day. And the story is that you're like on the North Pole helping Santa doing stuff. Anyway, and then yeah, so first it starts off quite easy, I would say. And then it gets harder and harder and harder. Yeah, it's been fun. And then every year since 2020, I've streamed it live on Twitch. And there is a competition. So if you go on leaderboard, these are like the people who solve it right away. And then you get like stats. But I'm not competing with anyone. I'm just doing it for the fun of it. Yeah, I mean, it's all Haskell, actually. Let me see. I want to short circuit this even further. So this one ends up being just the path, right? Okay, so I want to say here that I don't care, and the R state, so R state of let me see, so stocks FG last P cast fp. Press show int and fg. We're gonna go fg plus 1. So now, instead of like, when it finds something that's higher, it doesn't have to search again and again and again for that, right? No, I don't have one yet. I am working on getting one. An important distinction. What do you do with that qualification? Well, I do research. Like the other day, I got my paper got accepted. I mostly do work on automatic program repair. Oh, what will I do with it? I mean, yeah, I mean, we do research, right? I might work at like at a consultancy doing Haskell stuff. But it's also, you know, it's more like, I want to say joining a church, right? It's like, you know, you get a master's so you can get a job with your degree, right? But you don't do a PhD because of the qualifications. I mean, sure, if you want to do like, if you want to do something like, you want to be in academia, like you want to be a professor or something, yeah, then you need a PhD as a qualification. But it's also just about, you know, being able to do research, right? Being able to come up with ideas, you write a paper about them, and you work them out, right? And then you can kind of take and that's what research is, right? You've done, like, if you do your research, and it's this idea of how do we, you know, in a good way, kind of further humanity's knowledge, right? And that's what I like, you know. I was when I was thinking about it, I finished my master's and I thought, do I want to just get that money, or do I want to do something that's, I want to say meaningful, right? Yeah, I mean, it's like normal science, but it's a bit different in the sense that it's more like math, right? So we're more trying to figure out, like, you know, making up systems and then discovering their properties, right? Whereas normal science, you know, you're more talking about systems that actually exist, right? Like the body or the cell or a virus, right? Whereas we're more like, you know, what if I made a programming language that did it like this? What if I, you know, if I have a system that has these properties, what can I do with it? What is an example of research that you would do? Wow, good question. I have a bunch of papers. This is like, well, this is what I published at ICSI. And there we had this program called Proper, which does automatic program repair. Right? Where, so you have some properties about your program, right? And then we fix it, right? We take the program, we poke holes in it, we run quick check, which is like a testing framework that generates test cases, basically. So you have properties. We can take those properties, we can take the tests, we can localize in your code where it fails, and then we can repair that, right? And then we can synthesize code, right? To replace your old code. So like here, right? So here we replace product with length, and here we replace product with sum. And it kind of works, you know. We could solve stuff. You know, non-trivial programs like adding the not is space. That's quite nice. But, you know, and then that's the thing, right? Like, we spent so much time debugging, right? And repairing programs, right? So what if we could automate that, right? And, you know, no one knows how to do it. Well, I mean, we have ideas. Some people are using like neural networks. I'm doing more classical stuff, kind of like constraint-based AI. And then like the paper that got accepted 2 days ago, that was on generating properties or synthesizing properties using these this new data structure called ECTAs, where you can actually, I'll just show you, searching entangled program spaces. So this is the data structure we used. So this is Jimmy's paper. This guy, James Koppel. And then this is Nadia Polyakopova, and she is super good at program synthesis. Armando, he is the guy who invented what's called sketches, which is this typed hole based thing where you yeah, so use that to generate properties. So question is, well, would it work to complete, fix, heal something? The knowledge of what's supposed to be there needs to be known, right? Yes, that's why we are doing that's why we don't just do unit tests, right? We do properties. So you actually specify, I mean, you have to specify what your program should do, right? So you can give it a type. The type can tell you what the program can do. You can give it, and you give it a spec in the form of like a quick check spec. And that's why, you know, our follow-up paper, right, was kind of how do we generate more tests, right? Like, how can we take your code, generate a bunch of properties, now like one property that will generate data, and then test that your code, like it will test that when your code holds, like the output has some properties, right? So it's not just one unit test, right? It can be the equivalent of 100 or 1,000,000 units, right? So we take your program, we generate those properties, right? And then we can feed that into the automatic repair to repair the program, right? And of course, the properties can only be generated if your program already works. So, you know, that's one of the things you could do, right? You can take like a known version that you knew worked, right? Now it's not now, and then you find something that doesn't work, and then you can generate the properties, and then you can find, okay, you know, how can I fix it so that it still like has the old properties? So it's like write creative AI that writes stories or makes art. Yes, except, right? So that's the thing, right? The AI is super confident. And it gets the big picture, right? Like it's convincing. It seems like it's correct, but it will get the details wrong. Like it will just say 1 + 1 is not 2. I mean, we'll generate a whole paper and we'll just have random errors, but the general outline is correct, right? So that's where we want to come in, right? We want to So, I mean, and that's kind of the future, right? You take these AI generators that generate something that's the outline is correct, it's almost correct, but the details don't make sense. And then we feed it into this more classical system, like I'm working on, to repair the general outline, right? And after that, you just write the yeah, I mean, these are good questions, right? Is this further along than ChatGPT? I mean, it's different, right? I don't think you can. So, I mean, the guarantee is also that, like, if the program is repaired, it's correct according to the spec, right? ChatGPT makes no guarantee that the output is correct, right? And, you know, there's a huge difference in almost correct and looks correct, right? And that's where, you know, that's why it's hard, right? Because we, you know, if you want to run a code on an airplane, you cannot ask ChatGPT to generate the code because it might be wrong and then a lot of people might die, right? So that's not what we want, right? So we want to be able to be confident that our code works. And then, yeah. Okay, I think this will get the one for this one. Let me cancel it for the example. Let me just run it for the input. Beginning concept for nano machines. I don't really know. So what do you mean by nano machines here? Huh. Yes. Well, a little bit. Yeah, we're writing the tools that kind of you have to synthesize the nanomachine has to be able to understand what are the possible shapes that you could become in order to repair whatever you're trying to repair, right? And yeah. But yeah, so that's why I like doing research, right? Because, you know, you're not constrained to current events. You can be like, okay, what do we really want, right? Not like, what can I do with the tools available to us now? But like, you know, if I could create the tools, what would I want, right? Hmm. I mean, that's kind of the idea, right? With integrating something like ChatGPT, right? They give a prompt, and then they can generate a bunch of stuff, and then you can fill in the details, right? But that's also the point with science, right? Is like the ChatGPT people are working on ChatGPT, and I'm working on the part where it takes that output and makes it complete. Right, so I'm filling in the details. Yeah, I mean it's cooperative. Right? I had contacts at Copilot, right, the GitHub people, and we were thinking of doing something with them, but yeah, it's always hard because like the person I knew, they didn't have contacts high enough, so they couldn't really like host me as a research intern. And then if I'm not hosted there, it's really hard to get good feeling for what they're doing and how it works. So let me just make sure that wait a minute. VS Code takes up so much memory. Yeah, I think it's cool, right? And then, it's also like, yeah, I'm doing a PhD, but I also, I do get paid for it, right? So not as much as I probably would, on the market, but it's still okay. I can afford this streaming setup. That is something. Okay. Oh, I'm not supposed to multiply with equality levels. So we'll need to get the... What other cool things am I working on? Yeah, we can show you the spectacular paper. So this one just got accepted to ICST. There's out of the double blind, so I can actually talk about it now. This is the one where we're generating properties. So you give it some kind of thing to reason about. So the idea is, and then later we have to... The plan is to be able to kind of take in a full program, and it would kind of pick out the interesting parts and run through those. And then this is the EZTA stuff. And then so this is what we do, right? We create this data structure that can efficiently represent all terms. And the key here is efficiency, right? Because if you're generating programs, like there's a lot of programs, so you want to be able to represent, 1 billion programs by, something that's a lot less than 1 billion bytes, right? With these ECTAs, you can do it in log time. So, 25 bytes or whatever to represent a million programs or a billion, but like 20, yeah, reduces the size a lot, right? And then you can operate on the ECTAs and do operations on them, and then that's as if you were doing operations on all the billion programs in one time, right? And this makes it super fast, and then we can kind of enumerate the programs, it's called, right? So you can kind of say, okay, what are the programs that you represent? And then we can take those and we can use quick check to generate these laws, right? And then we generate stuff like, 0 is equal to the length of the empty list, so it'd be empty. Adding to empty list would be empty. And then this one is cool. So if you map over the reverse of a list, that's the same as reversing. That's the same as doing the reverse and then mapping first and then reversing, right? And these are all like kind of laws that make sense if you, right? And so this one's also cool, kind of, right? So if you map over a list of concatenation of a list of lists, that's the same as mapping a function, mapping the map over that list and then concatenating. There's a lot of like these laws that we discover, and then we have some data, and we are a lot faster than our main competitor, QuickSpec, particularly for very huge programs, like huge lists, which has like 100 things in scope. We take 91 seconds, whereas QuickSpec crashes. And we've seen it crash and taking up like 250 gigs. What are laws? Laws are kind of laws are like these properties, right? Where you say, this is equal to this, right? So that's the idea with a law, right? Yeah, okay, so it was... This is the huge one that crashes, that QuickSpec just can't handle. It runs out of memory, but we can. That's one of the things I'm working on. Another thing I just did is this CSI Haskell. This is a poster only, actually. Where, here you have like a classic error in Haskell. It doesn't tell you anything. But what we can do is we can actually figure out what exactly was going on when it happened, and then output that, right? So you can add these traces, right? And this is key in functional programming, because things are like generated lazily and then they are consumed lazily. So like the distance, I'll call it, from values being produced to values being consumed is a lot higher than in imperative languages, right? Where you kind of generate a value and eat it up right away. But it's also, in some way, it's closer, right? Because you only generate it right before you use it. But so like the distance in code might be very far, but like the distance in time is very close. So by saying, okay, when you generate it, let me know what you did. This is like and this is like a GHC fork. And then I wrote this paper on type laws, like being able to sometimes weaken the type system in languages like Haskell, in the sense that you can tell it, or you can kind of make it so that you can do things that should not be allowed, but if you know that they won't break at runtime. And this allows us to test things that would otherwise be very hard to test. And then, of course, if you boot up Haskell, you go GHCI, and you say, I want a function that goes from string to IO. It searches the scope for you, and it tells you, you can use put string, ln read IO, print fail. And this is in GHC, and this is what's called valid hole fits. You can even do set f if 5-minute level hole fits equals 1 or higher, and then it would actually not just tell you things that like directly have the type, also things that, like, if I write file, if I give write file something that takes a file path, like a file path, right, then it will actually have that type, and then that is a valid hole fit. Yeah, and I added that, and this is my paper on that. Suggesting valid hole fits for typed holes. And we had these. Yeah, super good for lens actually. And I had this super nice thing called subsumption graphs that kind of would give you the perfect order, like the most relevant ones first. But and it would be really cool in the sense that you could even, if you use type level hackery, you could even find you could sort by time complexity of functions. And I added this to Haskell, and now if you go to REPL it Haskell, you have it there, right? So, it's not just my GHC, right? It's everywhere. That's what I added. Yeah. And that's also that's where it started. That's why the title of my licentiate, which is like the halftime degree we do here. It's called The Whole Story. And it's quite nice. I like this picture. Anyway, I don't think you have to be smart. I think you just have to have the patience. Let me take this number here. Number 1 was 21. Number 2 was and I think yeah, I mean, and that's why why you ask, like, what are the qualifications a PhD gives you? And I think it's really, it's this, right? It's so that I don't understand any of these things either, but I know how to not understand things, right? So I know, this guy calls me up. He's like, I got these ECTAs. I heard you do testing stuff. Do you want to use them? Should we do? Let's write a paper together. I'm like, okay. Let me just look up this state-of-the-art synthesis stuff, and become an expert in it. And they cited me. Whoop, whoop. And then let me do something brand new with it, right? And that's what you do in a PhD, right? You're comfortable with not be understanding things, right? And then you can just do cool things that no one else is doing, right? Because but then if you go to Haskell, the holes guy, right? This is just me. I remember Eisenberg was like, "Hey, Maddie, you are the holes guy. Do it." So you own a feature, right? Yeah. And this is you get to work on the cut, like Christian was saying, right? You get to work on the cutting edge, right? And also, like this repair program, like you can, right? But it's not like you can just download it and start using it right away, right? It's more like, it's out there. We're trying to figure out how do we make these things. What are the things we should not do, right? So there's a lot of mistakes, and what can we do that makes it work, right? And then once you figure that out, like these, right? Look at this. This is Version Space Algebra, VSA, by Gulvani. Okay. This is how we represent expressions. Okay. This is how they represent expressions in version space algebra. Now, where have you seen version space algebras? If you use Excel, that magic feature where you can drag down and it just makes things up for you that just work, that's VSAs, right? That's this guy here, Gulvani. A legend in the biz. Okay, and then and let's look at that. Gulvani. Gulvani. Oh, these are like locked behind paywalls. Which I do have access to at work, but not right now. Here we go. Automating string processing in spreadsheets using input-output examples. Oh, okay. I don't even have access to this one. I do have it in my Dropbox. I should probably not share that on stream, seeing as it's super copyrighted and not by me. Anyway, this is open. So it's cool, right? Like it's these.
In the column 1 into the currency shown in column 2.
It's these features, right? Like these magic features that come out of research, which is why we do it, right? Which is why we must do it. Anyway, do I recommend doing a PhD? Probably not. It's very long. I'm in my final year now, but it's taking me. It's a 5-year program. You do get some papers accepted, but usually you don't get them accepted. Like, you have to put a lot of work in. You have to learn how to write papers. You have to learn how to, convince people that are a lot smarter than you that your paper should be accepted, while someone else who also is very smart submitted a paper. Their paper did not get accepted, right? And so you have to sell your paper, right? So you learn a lot of good writing. You learn how to do that, right? You learn how to do the work so that your idea, right? Let me make typos, right? How do you take that kind of idea and because a lot of these just end up you write something in a GitHub fork, right? And then it never ends up anywhere. So how you take it to completion, right? And then, you get a job at Microsoft. You add it to Excel. A lot of Haskell is actually funded by Microsoft because they were paying Simon Peyton-Jones at Microsoft Research Cambridge because Excel is like a functional programming language actually. It's all about data flow. It's all about functions. And I think so. I think that's the fun part, right? You don't call up a PhD in computer science and have them work on your problem, right? It's not like, I have an idea for an app, let me get a PhD. It's more like, we're the people in the background, right? Doing the work, and then that ends up, like C, right? Or like C is written by 2 PhDs. Right? There's a lot of PhDs involved in Rust. There's a lot of PhDs involved in Haskell. A lot of PhDs involved, at Facebook, making Facebook fast, making TypeScript. Now I'm saying programming language things because I'm a programming language researcher, right? All that machine learning stuff, it's all PhDs. But you don't see them, right? Because they're not. And I think that's also the point, right? Like if you do a PhD, you're not so much in it for the glory, right? You're more in it because you feel like you don't know enough about the world, right? And we need to know. We should know. And we must know. This is Hilbert's quote. Yeah, but it's fun. I recommend it. If you enjoy it, it's really fun. If you don't enjoy it, it can be very hard to do. And yeah, so it's also about stamina, right? It's like great chess players, right? Great chess players, they're smart, they're good at thinking, but they have excellent memories. And the best ones are just really good at playing for really long times, right? Like they'll just playing chess for 8 hours, right? I think that's the same with research, right? You have to have not just stamina like per day, but you have to take a problem and you have to not understand it for months, right? And you don't have an answer, and it's an unanswered problem, right? Like if there was an answer, you would not be trying to write about it, right? So there's no one there. You can't ask anyone. You can't be like, let me go to Reddit and get a hint, right? It's not like that. You have to be okay with that, and I think that's a reason why a lot of people they drop out of PhDs. It's not like, they can be very smart, but that's not really what a PhD is about. It's about being comfortable with not knowing, right? And I think that can be very hard for some people, right? If you're always the smartest and you always knew everything, and then you do a PhD and you were sitting with professors, they're like, and you're like, like me, I'm like 31 now. Yeah. And there's people there that like, they were full professors at 27. Right? Like, and these are extremely smart people, right? You'll be bashing your head in on a problem for a week, and they take one look at it, they have no context, and they're like, what about this? And it's like, oh yeah, okay, that's exactly, So you get to interact with those people, right? And you get to, and you get to be the dumbest person in the room, right? And I love that, right? I want, I think that someone said that, like, if you're the smartest person in the room, like, you should find another room, right? Because you're not gonna learn anything if you know everything already, right? And I think I like it. I like being able to, not know anything, and then, nobody else knows anything, so it's fine. I really should have written this. Thanks, Christian. Yeah, I think this will be over soon, and then I'm gonna go sleep. I really should have written this DFS and not as a kind of look at the path and then check. I should have just been like, search this part of the space and then give me the biggest number. But I don't want to cancel it now. Find out. Yeah, that's kind of exactly what I should be doing. Let me just check if this works. So this one was 31, was 39. But I want to see what this one does. Val start. V. Okay, now this one takes a left gene, A, Z, A, and Z. Right, and then you want to do max val A, val NAS prime. We're not gonna have the end function here actually. And this one is supposed to be the val function, right? Which is our state. Let me see. Let's see, 39 plus 21 plus 7. Let's see if it's correct. Multiply them together. 39 times 21 times 7. Oh no. It didn't work. Wow. Okay. Let me see what DFS max says. Oi, sorry. Alright. Yeah. Yeah, you can program these androids, right? They should not be too bad. Hmm. Yeah, it took half an hour to run. It gave the wrong... So some of the assumptions must be wrong. Yes. Sorry. Because I thought this would work, right? I did it just a slow way. But it did not work. $21, $7.39, $5.733. This determine a larger combination needs of the first 3 blueprints. Just talk, make sure to believe it, that general shipped. It was 32 minutes, right? Yes. Maybe that make only geode if you can is wrong for one of my... Okay, we'll take that away. I'm thinking of saying a good for the night, as we say in Iceland. I don't know what's wrong now. I removed this one part that's possibly unsafe. And now I'm just going to run it for the night. And see what happens tomorrow. And then I guess I'll have to do a part 2 for this one. We already spent, almost 7 hours today. And we only did task 1. But I have to say, we're not the only ones. Okay. But yeah. It was nice to have someone here. Chat about research while waiting for this to finish. Because, otherwise you just sit on your program and not chatting with anyone. Hope to see you tomorrow. Again. Follow. And then you'll see when I'm online. And Aaron did follow. And then, tune in next time. And let's continue the conversation, right? And then maybe this will be done. And I'll see what went wrong or something. But yeah, it's gonna run for the night. And then hopefully not crashed. Alright. I'm getting super tired also. I think that's why my energy is falling also. Yeah, but also ask questions, That's why we're also doing this in Haskell. We're trying to see if it's good stuff or not. Yeah, same. Yeah, the sleep is calling to me. Alright. Good night, Aaron. Good night, the rest of you. And see you next time. Alright. Bye-bye.